Hello everyone. Today we will deal with the chapter Electricity of Standard 10. In this chapter, as an introduction, we will know more about conductors. What are the two types of conductors that we can generally say? They are metallic conductors and the second category is ionic solutions. In metallic conductors, what contribute to charge conduction? That is, the free electrons in metallic conductors. We know that there are a lot of free electrons in metals. In ionic solutions, of course you know, ions are the charge carriers. So, in this chapter, we will be primarily dealing with metallic conductors and their properties. So, now let us study about an electric circuit. In your previous classes, you have already studied about electric circuit. Now we are going to draw it, and you can draw also. An electric circuit primarily consists of a battery, which is a collection of cells. That's the basic difference between a cell and a battery. A cell is a single entity. A battery is a collection of cells. Then after that, we'll go for a switch which is closed, I say. Then we can connect a bulb over here. And you know, as you have studied in previous classes, the bulb will glow. So here, the current is flowing, as you know, and the bulb glows. So, how can we define this electric circuit? An electric circuit is a closed and continuous path of electric current. What is an electric circuit? It's a closed and continuous path of electric current. So, now we are going to discuss an open circuit and a closed circuit. We know if the switch is open, what happens? There is air in between, there is a gap in between, and you all know this air is a bad conductor of electricity. So no electricity can pass through it. So this can be called an open circuit where the switch is open. The switch is not closed. So when the switch is closed, what happens? The circuit is continuous so that electricity can pass through this and make the bulb glow. When the switch is closed, what happens? There is a flow of electricity. So this is called a closed circuit. So once again, taking a recap of what is an electric circuit. It's a closed and continuous path of electric current. So now we must discuss something about the direction of flow of free electrons in the conductor connected, or the direction of flow of current. We know that electrons, they always is given by the battery's negative terminal. So the battery's negative terminal will give out the electrons, so that the electronic flow in this circuit is like this. And of course we know that these electrons having a negative charge, it is always attracted towards the positive terminal of the battery. But the direction of the electric current, the conventional sense, the direction of the electric current is from positive to negative. So, what is it? The electric current is flowing from positive to negative of a cell. This is the current direction. You may note it, that's a concept. What is the direction of electric current? The direction of electric current is from the positive terminal of the battery to the negative terminal. In which direction the free electrons move? They move from the negative to the positive. So conventionally, the direction of the electric current is opposite to the direction of flow of electrons. Now, let us learn the concept of current. Okay, when we say current, it's electrical energy. Current. So, let us draw a cylindrical conductor. Suppose this is a cylindrical conductor. What I shade here is called the area of cross section. Area of cross section. So how many areas of cross section are there? Numerous. So if we can assign an area of cross section here, it will look like this. For a cylindrical wire, the area of cross section is always a circular area. Okay, so suppose a person is standing here and he is having a stop clock with him so that he takes some time, not some time. At that time, he is looking here that how many charges will cross this cross section out. Here the charges means the free electrons. So the number of charges or the amount of charge that is flowing out of this particular cross section in a given time is what is meant by electric current. So electric current may be defined as the amount of charge that is crossing every cross section of a conductor in unit time. So once again, taking a recap, electric current is the amount of charge that is flowing through any cross section of a conductor in unit time. So that is the definition. Now we have to deal with the mathematical equation of electric current. So let us write the mathematical equation of current. So current is represented by the letter I and the amount of charge is represented by Q and the time is represented by T. So we will get the mathematical equation. Current is the amount of charge per time. So whenever we write an equation, we have to think for its unit also. So let us look at the unit. What is the unit of current? The unit of current is ampere. The unit of current is ampere. The unit of current was given in order to honor the scientist Andre Marie Ampere. So the unit of current is ampere. The unit of charge is coulomb. And the unit of time is second. So ampere corresponds to coulomb per second. So what is 1 ampere? It is 1 coulomb per second. So 1 coulomb per second is called 1 ampere. Coulomb per second or ampere is the unit of current. So here there can be a definition question to you. Define 1 ampere. What is 1 ampere? It is the current passing through a conductor when 1 coulomb of charge passes the cross section of a conductor in 1 second. So we know the unit of current is ampere. But there are certain instruments. Suppose some electronic instrument which needs only a small amount of current. So sometimes the current unit can be milliampere and microampere. Milliampere means 10 raised to minus 3 ampere and microampere means 10 raised to minus 6 ampere. So milliampere, microampere, ampere, these are all units of current. So now we will be dealing with how we can measure current in a circuit. So I'll draw the circuit as we have drawn it earlier, and a closed key is there, a bulb is there which is glowing. So how can we measure the current in this circuit? Current in any circuit can be measured by an instrument called ammeter. So we can fix an ammeter in the circuit. Usually we say that an ammeter is connected in series. But why it is connected in series, or what is the type of a series connection, that we will look in further videos. So when we have an ammeter, we will connect it like this. This is the symbol of an ammeter, and the positive should be always towards the positive of the battery. So this is how we can measure the current passing in a circuit. To conclude with, we will discuss one more concept. There is a question in your textbook. What is the number of electrons in 1 coulomb of charge? What is the number of electrons in 1 coulomb of charge? So, for explaining this question, we need a concept called quantization of charge. Quantization of charge. We know that materials can be charged, and a charge on a particular material is plus or minus an integral multiple of electronic charge. This is what is meant by quantization of charge. So, what is the electronic charge? You know that you have studied in your previous classes. An electronic charge is 1.6 into 10 raised to minus 19 coulomb. So, the question, back to your question in your textbook. What is the number of electrons in 1 coulomb of charge? So, what is given in the question? It is the charge given in the question. So, what is it? It is 1 coulomb. The charge given is 1 coulomb, and the electronic charge is 1.6 into 10 raised to minus 19 coulomb. It is minus because electron is negatively charged. So in order to find N, what we have to do? It is Q by E. So what is Q? It is 1 divided by, what is it? 1.6 into 10 raised to minus 19 coulomb. Only we are taking the magnitude of the electronic charge. So that we'll get an answer that is already given in your textbook. So just check for it. There is a number given like 6.25 into 10 raised to 18, like that. How will you do it? We can write it like this, right? Into 10 into 10. So we'll get it as, what is it? 10 by 16 into 10 raised to minus 19. Okay, we can take this up and we can write it as 100 into 10 raised to minus 8 plus 18 by 16. So you'll get the figure that is given in your textbook. Please check with it. Thank you.